Hello everybody, my name is Julian. Today I'd like to talk to you about this. This is called the BANDIT. It's a completely standalone computer keyboard that runs ColorForth, or a variant of ColorForth called PC32. It has 32 keys and you only need to provide a VGA connection and some power in order to have your very own standalone ColorForth computer. So let me just connect the VGA and the power, and if I turn it on and wait for the monitor to sync, you will see that I have my editor here, where I can just type something like a hello world, or something else, something else in the SV fig. Where is the G? Here. Okay, I can change the color of the letters because it's ColorForth. But more to the point, what is the Bandit? Well, the Bandit runs on an RP2040, and in the future it will run on an RP2350, and it runs at 206 megahertz. It runs bare metal. It has about 260k of memory in total, but the next version will have close to about half a meg of memory. The base compiler and the bootloader are around 3k of object code. It runs on a VGA interface, as you saw, but it runs at a quarter VGA at 320 by 240. It's going to be double buffered. This version that you are seeing right now is single buffered. I am starting the next frame right around here, so I am in a sort of way tailgating the frame buffer. It's a 32 key keyboard, and it uses chords for a lot of things. For example, there is no space. Space would be these two keys. And it also has a battery back QSPI memory, which gives it an extra 8 megabytes of storage. The final secondary storage is the SD card, but in the future you will be able to connect to a PC via wireless, and well, there's also the sound coming next. So the ColorForth version of this Bandit computer, it's a variant called PC32. It uses 16 colors, and it encodes the tag of the color in the space before the letter. It also encodes the length of the tokens. As you can see, there is define call numbers, reference, data, which access the memory, like in Mr. Chuck Moore original ColorForth, the magenta variables. It's similar, but I also use it for strings. There's also the assembler and the shadow tag, but there's also blue words. So if I press this combination here in the keyboard, you will see that it shows me the blue words right here. So you can see there's editor here. So if I press it again, it will go away. There is the second context, which is the execution context, which will have the jump, immediate call, immediate number, immediate reference, and so on, except this one, which is not immediate assembler, but it's instead a macro which will inline some code. Of course, I also have my editor, which is an important part of the traditional ColorForth. You can have the blue words. You can also have a command word where you can just type stuff here. Let's say I type 1, 1, and then I add them, and I get a 2 down here. So I can get out of that. I also can cut and paste like this. I can also copy and then paste like this. Of course, I messed up my formatting here. I also have source lookup. So for example, if I look up the word dupe and I go to the source, you can see it's right here, and it goes right back to the core of the compiler. So next, I'd like to show you a few demos. So here is the traditional burst, which will use the Bressingham line algorithm to draw from a point. And if I continue, you will see that it starts doing a lot of rays. I can get out of that, and I can move to the next page. Here we can see something about the graphics. I am doing 4-bit graphics, which gives me 16 colors, and I am also doing 8-bit graphics, which give me 255 colors. The difference is in the packing. In 4-bit, I can pack 2 textures per image. So the lower nibble and the upper nibble is one texture. They're interlaced, and the 8-bit is just straightforward 8-bit color. So if I show you something here, this is my texture editor called TextEd. If I execute it, you can see that I've been drawing some stuff here. So let's say I change the color and I want to draw something like this. Right. So I just rented my masterpiece, but hang on, let's see if I can feel this. I can feel it. I can change my colors, and let's see if I can build this. And I can also go and change the palette. For example, if I want to, let's see, where is it? If I want to change the background color to this blue, and I get out, now you can see that my palette is changed, but now it looks horrid. So let's just put it like a very light color. Let's see, this was black. And well, now I ruined the masterpiece, right? So let me just change it back to black, and let's change the background color, which is transparent, to something like this clear. And if I get out, well, there's a lot more contrast. So let me get out of that and go back to my presentation block. And now let's see something a little bit more advanced. I can do sprites, so I can do a ton of sprites moving at the same time on the screen. This part here is a perspective projection, which uses the interpolator of the RP2040. If I go to the next demo, you can see it's a moving sprite, and you can see the lines going like that. Now, I can probably, let's see, I can probably load this. This is a large background image. It's about 960 by 240, and well, you can see that running the DMA starts running the frame buffer starts making this ugly line here. So I'm going to be naming the second frame buffer next. And to combat that, I used let's see, where is it? I think it was this one. I made a tile editor, so if I run that one, you can see that I can take a texture here, pressing Q, and use where is it? Where is the cursor? Let's see, it's down here. I can take part of the texture. Let's say I take this here, get out, and I can place it down here, right? Like this. I can copy the previous one and continue building my graphics like that. So the whole battery back thing is very important. So if I turn it off, turn it on again, you will see that I am back where I was and my changes are saved. So this allows me to work like in the original ColorForth, where you would load the entire memory into the memory space, or the entire source code into the memory space, and not bother about loading and saving files. So the battery back memory allows me to do that. Now, finally, let's see. Well, I couldn't attend this meeting But if you have any questions, please you can write me to my email at tide or at dscf.co.uk. My webpage is dscf.co.uk. You can read more about the PC32 language, and I am slowly updating it with links to my videos and so on and so forth. So thank you very much for watching. I hope you have a very happy fourth day. Take care.